This video is going to be a complete guide to selecting the right coupling for your any machine or product design. And we can divide the coupling selection procedure into 3 basic steps. First step is the selecting right type of coupling on the basis of required accuracy in motion transfer. Means acceptable backlash of the application. Like for servo motor application, we select zero backlash coupling. And for the general application, we select simple jaw coupling to save the cost. And selection of type of coupling also depends on the type of misalignment and the amount of misalignment in that application. And after selecting the right type of bearing, right type of coupling, the second step is the selecting the right size of selected type of coupling. Size of coupling means rated torque of coupling, which depends on amount of loading torque, or the motor means driver torque, like coupling size for 2 HP motor, and the behavior of torque loading in the application, like constant stationary torque loading or shock torque loading means peak torque loading. Because as per the loading behavior, we have to consider appropriate factor of safety over the amount of actual torque being transmitted. In constant loading condition, we calculate coupling's rating torque, and in peak torque loading condition, we make sure the coupling permissible maximum torque. We will understand this with example later in this video. And finally, in third step, we can select the coupling hole size and the type of interlocking method, like shaft clamping or key slot or with set screw. So in this video, first we will try to understand all the technical terms, all the technical parameters related to the coupling, like type of misalignment and how to calculate it. Also, what is the backlash of coupling, and also the permissible speed limit of the coupling. And on the basis of these parameters, we will understand different type of couplings and their selection as per the application and the type of motors. And then with example, we will learn how to calculate the rated torque and the permissible maximum torque of the coupling, and what are the factors of safety we should consider. So let's start from very basic, completely basic. What is the coupling? So as the name suggests, coupling means a device which connects two things together, couple the two things. For example, the pipe coupling, connecting the two pipes together to transfer the fluid. If you are from HVAC industry, you know the better. But in this video, we are going to learn only about shaft coupling. And we can define the shaft coupling as a mechanical component which connects two shafts together to transfer the power from driver shaft to the driven shaft. But a coupling can also observe misalignment between two shafts while transferring the power. What does it mean? So let's understand this with an example. So let's say this is a motor shaft, means the driver shaft, and this is a ball screw shaft end, means the driven shaft. So to transfer the power from motor shaft to this ball screw shaft, let's suppose if we connect this shaft together directly, let's say we just weld it permanently, then a lots of problem will arise here. The first and most obvious problem will be we will become restricted in disassembling the motor and this ball screw for any sort of purpose, like for maintenance, or maybe we need to change the motor. We cannot disassemble. And the second problem will arise because of misalignment between these two shafts, because we know that all the parts cannot be perfectly manufactured and cannot be perfectly aligned. And a permanent joint cannot compensate for any misalignment between these two shafts. So a misalignment will be apply an unwanted pressure over the motor bearing and the ball screw support bearing, and as a result both will fail very quickly. And this is why we always need a coupling to connect two separate rotating shafts, which not only connects two shafts to transfer the power and make it easy for assemble and disassemble, but a coupling should be also capable to absorb the required amount and type of misalignment between the shafts. And there can be 3 types of misalignment between two shafts. Number 1, lateral misalignment, or we can say eccentric misalignment, which means a parallel offset between both shaft axes. Second is axial misalignment, which means a significant tolerance in the distance between face of the shafts. In most of cases, lateral and axial misalignment are kind of a static misalignment during the motion, and the third type misalignment is the angular misalignment, where shaft axes are not parallel and they are at some angle and create a dynamic misalignment. But in between the shaft, there can be also a combination of misalignments, combination of 2 or 3 type of misalignment together. But here you can ask that Ayush, we usually make the order of coupling during machine designing stage. So how I can measure the misalignment, amount of misalignment or type of misalignment before manufacturing, or how we can make the selection of coupling during the designing? So as a design engineer, we always consider the worst condition. And what could be the worst misalignment between these two shafts? So in this system, if all the parts are manufactured as maximum allowable deviation and then assembly is also done at the maximum deviation, then it will be the worst condition. And we can calculate the maximum deviation using tolerance stack-up analysis. So just for understanding, let's do a casual stack-up analysis. We will understand the tolerance stack-up analysis in very detail in separate video. But here just do a casual stack-up analysis. So let's start from motor side. So usually we fit the motor in H7G6 fit. And for the diameter 114 mm, the maximum deviation will be 0.07 mm. And let's suppose the position of motor mounting hole with respect to the bolting holes is 0.1 mm. And as the bolt mounting hole clearance is 0.5 mm. So in total this will become 0.67 mm. And on the ball screw side, the bearing mounting fit is again H7G6. So for the support bearing diameter 63 mm, maximum deviation will be 0.06 mm. And the position tolerance is, let's say, 0.1 mm. And again, mounting hole clearance is 0.5 mm. So in total, it will become 0.66 mm. Means the total possible deviation after assembly could be 1.33 mm. And this is the possible lateral misalignment in the shaft arrangement. We can also calculate axial and angular misalignment from detailed drawing of the every part. But as for now, let's consider only lateral misalignment. So our selected coupling permissible lateral misalignment should be more than 1.33 mm. We will use this value to select the coupling later in this video. And now, a coupling should have also enough strength to transfer the required power. When I am saying power, it means transfer the torque at a given speed. Also, coupling should have enough strength to absorb the quick start and stop inertia of the whole system, and also the peak loading condition. But we cannot calculate all the uncertain torque loading. So we consider appropriate factor of safety over the driving torque, like operating factor, starting factor, temperature factor, and the directional factor. And the coupling rated torque should be greater than the amount of torque being transmitting, considering all the factor of safety, which we will understand with example later in this video. And now, a coupling have also a speed limit, permissible speed limit. The application maximum speed should be less than the coupling maximum permissible speed. So what does mean of coupling permissible speed? Why we should not run the coupling beyond permissible speed? What will be happen? So as we know, the coupling is meant to absorb the misalignments while rotating. So in misalignment conditions, coupling lose their perfect cylindrical shape, and as a result, unbalanced mass created, and an unbalanced mass generate vibration and centrifugal force over the coupling components. So the permissible speed of a coupling is the maximum speed at which we can run the coupling at rated torque under maximum allowable misalignment. And we can find this permissible speed limit of the coupling in manufacturing catalog for each specific size and type of the coupling. A speed limit of coupling also depends on dynamic balancing grade of the coupling. High precise dynamic balance rotating part means the less vibration during the rotation. We will also learn about dynamic balancing and their grades, because this is a very important control when we design for high speed rotation. And now, a coupling should be also capable to transfer the motion at required degree of accuracy, means under allowable backlash of the whole system. So what is the coupling backlash? So we can say coupling backlash occurs when the application torques results in greater shaft rotation at the one end as compared to other end. And this happens when coupling gets twisted by some angle while transferring the torque. And also if the coupling is made of multiple parts, then there can be a play between the parts in angular direction. This will also consider as a backlash. But in precise motion applications like servo actuator, coupling backlash makes problem because coupling backlash cause error in linear travel distance of the actuator. Also, the home positioning of the servo motor can be disturbed because of coupling backlash. So with a servo motor, we should always consider zero backlash coupling regardless of linear travel distance accuracy. Zero backlash coupling means negligible backlash in coupling, like disc coupling or Bellow coupling. These couplings are highly torsional stiff, means these coupling can transfer the torque without getting any significant twisting under their rated torque, which depends on coupling design, their material and the size. And we can also find the torsional stiffness of each model of coupling in their catalog. Whereas in many applications, we just need to transfer the power regardless of motion accuracy, regardless of backlash, like a blower or compressor or a conveyor, where we simply use induction motor to transfer the power. So in these applications, we can use any cost-effective couplings, like a jaw coupling, or for the large misalignment, the Oldham coupling. So we can categorize all the couplings in two main groups. One is motion control couplings, means zero backlash coupling, means the coupling which is designed to transmit the accurate motion at moderate misalignment. And the second group is the power transmission coupling, which means the coupling which is mainly designed for the power transmission at significant amount of misalignment. So in motion control coupling category, there are following couplings: the disc coupling, Bellow coupling, split coupling and rigid coupling. So let's understand one by one. Disc coupling. Disc coupling is most popular coupling for the motion control, and we get wide range of torque transfer capacity as per the size and material, and it's best suitable for the servo motor. Disc coupling consists of multiple thin discs. These thin discs piles up and provides torsional stiffness as well as absorb all three types of misalignments. But here we have to understand a very important thing. The allowable misalignment of coupling we see in catalog are individual allowable misalignment value. But in case of combination of misalignment, these values reduce to its half. And mostly we ignore this, and as a result, our coupling get damaged. Also, a single stage disc coupling cannot tolerate any amount of lateral misalignment. So if the shafts are not perfectly aligned, go with the multi-stage disc coupling. Second is Bellow coupling. A Bellow coupling is consists of single Bellow shape sheet metallic piece. Bellow couplings are also comes in wide range of rated torque depending on the size and the material, and suitable for the servo motor as well as for the stepper motors. Next is a split coupling. A split coupling is also a single cylindrical piece with multiple cuts to adjust the shaft misalignment. But a split coupling are not much suitable for high accurate motion transfer. We use a split coupling mostly with the stepper motor. A split coupling are very economical and lightweighted because this coupling is mostly made of aluminium, and this coupling rated torque range is less as compared to disc coupling and Bellow coupling. Next coupling is the rigid coupling. Rigid coupling are simply a hollow cylindrical metallic piece having highest motion control accuracy and the most economical one. But this coupling cannot accommodate any misalignment. So we use it only where the shafts are perfectly aligned. In rigid coupling, we can find multiples design like plastic and cup coupling, nut and bolt type, pin and flange coupling. Also this clamp type coupling. And there are also some special design couplings which we can use for motion control if the torque is very high, like chain coupling, which consists of duplex chain and separate sprockets, something like this. Also comes with cover. They are economical as compared to disc coupling and Bellow coupling in case of high torque transmission, but their maintenance is high and also it's little noisy. And there are one more motion control coupling for high torque like 1000 Newton meter, precision shaft fitting coupling. They are economical as well as robust design, and I personally like this coupling. I have used it in high torque servo motor machine. The running was very smooth and also suitable for large misalignment condition like for up to 1 mm. So these are the all types of motion control couplings, and they are backlash, rated torque, permissible misalignment and permissible speed depends on size, material and manufacturer of coupling. And their price also varies with manufacturer to manufacturer. So always first list down all the qualified couplings as per your requirement, like amount of torque, required misalignment compensation and required permissible speed in coupling, because all these couplings are zero backlash coupling and all can be used for the motion control application. And then finalize your couplings by cost comparison from one manufacturer or maybe multiple manufacturer, because these couplings are really expensive. Next coupling category is the power transmission coupling, which are jaw coupling and Oldham coupling. Jaw couplings consist of a spider-shaped rubber in between two jaw hubs. So we also call it a spider coupling, best suitable for general motor, low cost, high torque transmission capacity, as well as moderate to high misalignment compensation ability in all three types of misalignment conditions. And we can also replace this spider rubber as a spare part when it's get wear or tear. Next is Oldham coupling, which is best suitable for large eccentric misalignment condition, having high torque transmission capacity, and their design is something like this. The middle part is slotted and allows sliding movement of both ends of the coupling, but this coupling cannot tolerate angular and axial misalignment. Also, this coupling have a temperature limit, because at high speed the temperature shoot up because of sliding friction in coupling. And for the general applications, there are also some special couplings for high torque transmission, like rubber flex coupling. This is like a tire, which can transfer huge amount of torque as well as adjust high amount of any kind of misalignment. And there are many more like hydro coupling, magnetic coupling, which we use in special cases. So in summary, for highest motion control servo motor application, use disc coupling or Bellow coupling, because both couplings are easily available in the market. Most of manufacturers manufactures this coupling, and if the torque and misalignment is huge and both of coupling cannot meet the requirement, then go for the special couplings like precision shaft fitting coupling. And you can also go for the rigid coupling if the shafts are perfectly aligned. You can save the cost. And for the moderate motion control like a stepper motor application, low torque application, go with the split coupling, economical, easy available and negligible backlash. And for general application where backlash doesn't matter, where you just have to transfer the power, go with the jaw coupling. And for high eccentric misalignment, go with the Oldham coupling. And for the really large torque, you can go for the chain coupling or the tire coupling. So after selecting the type of coupling on the basis of application and the motor type, we can go for the second stage of the selection procedure. Sizing of coupling means calculation of rated torque of coupling. And let's understand it with example. Let's say in this actuator we have ball screw driving torque is 5 Newton meter and the application speed is 1500 rpm, and our selected motor is servo motor and the power is 850 watt. So the first step is the selecting the coupling type. So as this is servo actuator, so let's consider disc coupling. And here is very important thing. We usually make the selection of coupling our actual required torque. Like in case of actuator, ball screw driving torque 5 Newton meter is application actual required torque. But we should make the coupling selection considering motor maximum torque, means our driver maximum torque. Because of some reason, if actuator get stuck, maybe during the trial or maybe during the programming, then the motor will goes up to its maximum torque capacity and coupling can get damaged, permanently damaged. So always make the coupling selection over motor torque. And here, instead of motor torque, power is given. So either you can check the motor torque in their catalog, or we can use this formula to calculate the motor torque at given speed. So the motor torque will become 5.63 Newton meter at a speed of 1500 rpm. Also in motor catalog, the torque is approximately same because motor speed is 1500 rpm. And now we have to consider the factor of safety over the motor torque, and most of coupling manufacturers suggest considering 2 to 5 times the factor of safety over motor torque. ChatGPT also says to consider 2 to 5 times. And this is very large range, so this is not make sense to me. So I personally follows a German coupling manufacturer KTR, which defines the factor of safety separately for each type of application. Also defines temperature factor, directional factor and starting factor. I will leave this document in video description, you can download it. So as per KTR, if the loading torque is constant, the selected coupling rated torque TKN should be greater than multiplication of motor rated torque Tn into operating factor SB into temperature factor ST into directional factor SR. So the motor rated torque is 5.63. Operating factor SB, which depends on the type of application. So let's suppose we are using this actuator for wired pulling. So consider SB is 1.5 and the temperature factor is depend on ambient temperature. So let's suppose the ambient temperature is 40 degrees centigrade. So ST is 1. Next is directional factor. So same as the torsional direction means 1. Because we are not using any gear or timing belt to change the direction. So it will become 8.45 Newton meter. And let's say the sub diameter is 24 and 24. So we can find the disc coupling which should have the rated torque more than 8.45 Newton meter. So this one is suitable. The rated torque is 9 Newton meter. And this is how we calculate the rated torque of coupling in constant torque loading condition. But in case of frequent peak torque loading condition, instead of calculating rated torque, we calculate permissible maximum torque. And permissible maximum torque Tk max should be greater than the multiplication of sum of motor rated torque and peak load of the machine into a starting factor Sz into temperature factor St into directional factor Sr. And actually in this application the torque loading behavior is not constant, because when actuator reaches their end position they will stop and reverse the direction of peak load applies because of a starting acceleration and moment of inertia of the whole system. And when actuator achieve a speed, required torque settle down. I have explained this in very detail in this video. So let's suppose the peak load of the system is 8 Newton meter. 5 Newton meter was the constant driving torque. And this Sz is the starting factor, which is defined as per the starting frequency per hour. So let's suppose the actuator cycle time is 2 minutes. Means per hours this system actuates 60 divided by 2 means 30 times. And for the frequency less than 50, the Sz is 1.4. So put the values and it will become 23 Newton meter. So we can select this coupling which rated torque is 25 Newton meter. And here is a very important thing that I forget. The allowable lateral misalignment is only 0.4 mm. And as we have calculated, the permissible misalignment could be up to 1.3 mm. And in most of zero backlash couplings, you will get only that much misalignment, permissible misalignment like 0.5 mm. So I always suggest to use integrated motor mounting, something like this. Motor and bearing should be mounted within the same bracket. So we can easily achieve a possible maximum misalignment under 0.1 mm. And as the final step, as the third step, select the interlocking method. If there is a key in the shaft, we can select coupling with key slot, or we can also go with the bolt clamping. And if shaft is without key, then definitely go with the bolt clamping. And we can also check the slip torque to make sure the clamping force is enough. But never go with this set screw type. I just don't like it. It just damages the shaft. And this was all about the coupling selection procedure. And I hope this video was useful to you. And if it was, please give us a like. And not just like, also do subscribe. This channel subscriber ratio is very low. Your supports keep me motivated. So please do subscribe. And thank you so much for watching.